last problem of this very long homework, and this kind of harkens back to chapter 6. It is number 43, and it gives us AZT. And then what it does is ask us to draw the other enantiomer of AZT, and right here is where we're going to change it, where it wants us to change it. Okay, we need to change every one of these locations to make the exact opposite. And we're going to determine these later. This is S, S, and R, and we need to switch it to be R, R, S. So all we need to do is switch each of these, okay, to get that. So I'm going to draw it in the same fashion, just like we always do, and switch the dash and the wedge. So this N and its whole attachment, which I'm not going to show, is going to be on the dash and the H on the wedge. And again, switch here, put the hydrogen on the wedge, and the CH2OH on the dash, and switch here, put the H on the dash instead of the wedge, put the N3 on the wedge. Hydrogens, they showed them like they have stereochemistry, but of course we know with two H's, it does not. So that is the enantiomer there with exactly the opposite. Okay. So then B wants us to assign what I just did here, but let's walk it through. Okay, this is number 4, our H. N3, of course, is going to be number 1. Then if we go outward, okay, this goes to two H's, H and H, and up to a C. This goes up to an O, up to a C, and only one H. So this direction will be 2, and over here will be 3. 1, 2, 3, 1, 2, 3. So you maybe are asking yourself, but why did she write S? And the answer, of course, is when hydrogen is forward, it is the opposite of what it looks like. So it is S. Next one. Okay, over to an oxygen is certainly number 1. The hydrogen is number 4. As we go out, we go to a C, we go to a C, we go to an O, we go to an N. And O is higher priority than N, so this will be 2, and this will be 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. And hydrogen is back, so this one is also S. Here, this guy, this is number 4. Up to an oxygen is number 1. To a nitrogen, number 2. Down to a carbon is number 3. 1, 2, 3, 1, 2, 3 clockwise. And since hydrogen is back, we have R. Okay, next it wants to know what would you expect the rotation? Well, if plus AZT has a positive 56, then minus AZT would have a minus 56, because the only difference is exactly the opposite. And last but not least, it asks us the total number of stereoisomers. We have 3 chiral centers, and our formula is 2 to the N, where N is the number of chiral centers, so it would be 2 to the 3, so 8 is our possible number of enantiomers. And that is number 43 and the end of the chapter 7 homework.